Hello, in this tutorial I'll show you how to treat plurimodal distributions in PebbleJuggler. Plurimodal distributions are distributions which have more than one local maximum, more than one peak, and I'll show you how we can try to disentangle this plurimodal distribution into single monomodal distributions. I begin by deleting this image and loading other two lists related to the same sample, which comes from a reaction which resulted in a mixture of manganese oxide and manganese sulfide nanoparticles. I now press the Analyze button, decide to analyze the equivalent diameter, and you can see that the diameter distribution has two local maxima, two peaks, so it is probably or can be interpreted as the superposition of two different distributions. So I enter the number 2 here in the number of log normal probability this distribution functions to fit. Here appear a help window, which as usual I invite you to read before proceeding. Now we have to input graphically a guess parameters for the fitting of the log normal distributions to our multimodal distribution. First, I have to click on the top of the peak, one of the peak. It is important both the position and the height of the point where I click, because they will determine the position and the height of the peak. Then I have to input the width of this distribution by clicking on where I think the half width, half height is more or less. In this case, only the horizontal position is important, so about 120 I go to 60, and let's say this is the width of the first peak. The same for the second peak, here, and then more or less the width can be here. And now you're presented with your guess log normal distributions, which will be fitted to the experimental one. If you're satisfied with the guess, you press yes, start the procedure. If you're not, you can press no and give another graphical guess. I'm satisfied, so I press yes, and this is the result. The light blue and red lines are the two composing log normal distributions, and the blue stars represent the global log normal distribution, that is the sum of the two log normals. I think that I'm satisfied with the fit results, so again I press yes. In the log window you can find the results. Again, these are the parameters of the global distribution of 662 nanoparticles with a median of 11 and a standard distribution of deviation of 3, which is high, 27% dispersion, and in a way these are numbers with a real significance because they refer toward the nanoparticles. But we can also hypothesize that we are in presence of two different log normals, which parameters are represented in the log window. Log normal 1 has a median of about 10 and a standard deviation of 1.7, 16%, with a number fraction of about 72%. The second log normal has a median of 16 nanometers, with the standard deviation of 1.7 and 28%. This hypothesis is probably true because we know that we have both manganese oxide and manganese sulfide nanoparticles, and from independent information we know that this log normal is probably due to the manganese oxide and the larger one to the manganese sulfide. Of course, this procedure can be done for distribution with 3 modes, 4 modes, and so on, but you should also be suspicious because a fitting procedure most often gives you sub-distributions, but you should have independent information that this subdivision is actually real.